Good day, greetings. Today we're going to focus on the topic of the heating of the atmosphere. So, first and foremost, we're going to concentrate on the processes associated with the heating of the atmosphere. I would like to highlight that not all insolation, which is incoming solar radiation, is absorbed by the Earth's atmosphere. This word insolation, the in stands for incoming, the solar stands for solar, the ation stands for radiation. I want to get that cleared away before we start. It's just the abbreviation for insolation is just the abbreviation for incoming solar radiation. So as I said, that not all insolation is absorbed by the Earth's surface because some of it is absorbed, which is taken up, or scattered, which is sent in all directions, or reflected, which means it is sent back at the same angle. So let's take a look at this peripheral diagram. So I want you, my dear learners, to imagine that this is the sun here. I don't know if you can see it. This is the sun, and it is sending its solar radiations down to the Earth, which is the planet. So this solar radiation is absorbed by the surface by 46%. And then it is reflected. A reflection is just like you looking yourself in the mirror. When you look at yourself in the mirror, you see a reflection of yourself. So it is reflected by the surface back to where it came from. And it is reflected by the clouds by 17%. And it is back scattered by air. And back scattering just means it is sent in all directions. Some of it is absorbed by the clouds, and some is absorbed by water vapor, dust, or tree, which is 90%. This means that it is just absorbed by the atmosphere. So I hope that we now understand how the heating of the atmosphere works. I would like to go down to the factors that affect temperature. So first and foremost, on the factors that affect temperature, we have what we call latitude. So latitude is defined as the measurement of distance in degrees north or south of the equator. So the latitude lines are sometimes referred to as parallel lines because they are parallel to the equator. They are important because they are the ones that gives location of places on Earth. As as you can, maybe if you recall from the movies that you've been watching, a soldier from the US embassy or somewhere in the movies can be told that look at south around 30 degrees. You know, I'm just giving a beautiful illustration of how latitude helps us in the world to find location of places. It is it starts from the 0 degrees line, which is from the equator, and goes northwards and southwards of the of the globe. So it goes to 30 degrees, 60 degrees, and ends at the 90-degree pole. We're going to dive deep more into the latitude and longitude in grade 11. So another factor that affects temperature is the altitude. So it says here, air temperature decreases with altitude the higher you go. Therefore, mountains are colder than low-lying areas. It means that the higher you go, the more air temperature decreases, meaning that the mountains are more cold than lying low areas. For example, have you ever heard someone said or says that when you climb up the Kilimanjaro mountain, for example, any mountain, any high lying mountain, if you climb up the Kilimanjaro mountain, you'll find that it is more cold at the top more than at the bottom of the mountain. The bottom of the mountain is more warmer than the top because the higher you go, the higher the more colder it gets, due to that you are going into what we call the atmosphere. You are reaching to the first layer of the atmosphere. I hope that is very, very understood. So we're going to go to the third factor that affects temperature. This ocean currents. We have two types of ocean currents. This is the cold ocean current and the warm ocean current. So the cold currents lower water and air temperature, while the warm ocean currents raise water and air temperature. For example, I would like to show you this South African map. contains this two currents. So we have the cold Benguela current and the warm Algeciras current. So the cold Benguela current that is situated in the South Atlantic Ocean. Therefore, Therefore, you may hear people concluding that the South Atlantic Ocean is more colder than the Indian Ocean. It is because of the South Atlantic Ocean consists of cold Benguela current and the warm Angulus current. It is situated in the Indian Ocean. That is why Devon, the ocean, the seas and ocean of Devon, it is more warmer than those of Cape Town. I hope that is understood because of this is our South African map. As students, we must be more familiar with it. So the last but not least of the factors that affect temperature, it is distance from the ocean. So the ocean heats up and cools down more slowly than the land. Coastal areas, therefore, coastal areas are cooler than inland areas during the day. And coastal areas are warmer than inland areas during the night. I would like to show you this illustration to illustrate what I'm actually talking about. So we have what we call a sea breeze and a land breeze. So during the day, the earth is being warmed up, and the sea currently during the day is more cooler. So the cool sea breeze goes on to cool the earth while it's being heated up by the sun. That is why if you go to Durban or Cape Town, you will hear people talking about a nice breeze that heats the coastal areas. Then you feel amazing. The sea breeze is actually a cool experience to go through. It's a nice breeze that cools down the earth. So, but then during the night, everything is different. During the night, the sea is much warmer, but then the land is what is more cooler. So as the sea warms up, the cool air from the earth will go and cool the ocean, which is called the land breeze during the night. During the land, there's what we call a land breeze. With that, I would like to thank you, my dear learners, and good luck on your coming up exams.